Happy to be the first one here, and thank you for being awake that early on a Sunday. My name is Romain Beauxis, and I'm going to present today a couple of ideas I put together after working on managing dynamic content for a automation streaming software that I developed with Samuel here years ago. A little bit of myself. I live in New Orleans. I've been a software engineer for over 10 years, maybe 15 soon. And one of the things I love when I do software is to think about navigating between the higher level, the clean abstraction we can create as software engineers, and what goes on under the hood, where we actually deal with a lot of complex problems that we know how to deal inside a box and present something outside of the box that is neat and very usable for people and solves those problems internally. And I'll give some example of that. So what I'm trying to do today is, after having dealt with the hard problems, looking back and say, what can we do that simplifies it, that would be useful for other people? So a little bit of the context here is liquidsoap is the software that we have. It was created around 2004 by Samuel and David Baud. They were students at the ENS, the Theoretical Computer School. It's a language for media streaming. It's functional, statically typed with infer types. That was all the hype, but we're not here to talk about that today. And since then, because that's been a while, it expanded to a fully featured language with a pretty tight integration with FFmpeg. And that's that integration that triggered what we are going to talk today about. And especially because originally it was audio, and now it's doing audio and video mixing and streaming, which brought another level of complexity in terms of the kind of content that we handle and the kind of questions we have to answer when we create stuff. So I'm going to look at a script in liquidsoap. That's the way we used to do it. Take a minute to read about it, but essentially you're creating a playlist of audio files. You're putting a jingle, a file here that's used when the playlist is empty. We're extracting the audio, the metadata, and the track marks. We're taking a playlist of videos. We're extracting the video track. We're remixing here audio, video, and metadata from each source. We're adding a little text on it, and we're exporting to HLS re-encoding. That's the way we used to do it, where everything is decoded to a raw content, being PCM audio, U420 video, something that you can actually manipulate and add data to it. But one of the layers we've added since then, since the first time we came to present here in 2020, is that now we're able to do something very interesting, which is, instead of re-encoding, we have a copy encoder that takes the raw binary encoded data straight up of the files. Basically, it informs every single decoder here that they need to not decode and just take the packets of encoding content and repackage it for HLS. And it looks minimal in terms of scripting, but in terms of CPU and machine consumption, it's day and night, because you can have a 4K video here that's being processed, and re-encoding a 4K video is vastly different from just repackaging the encoded video. And so this is where the complexity arises, how you transfer what we do in streaming to the world of directly encoded data. Yeah, so liquidsoap can schedule hourly playlist, can support live source DJ that connect at any given time. It can have multiple output. And basically what it means is that it can handle dynamic encoded content. And at any time, you might switch between a stream and another one. You might change your audio, you might change your video, and you still want to be able to compose all this content and create a stream that's readable and compliant with the format that you're exporting to. And that's what we're trying to solve here, and I'm going to explain how we did it. It's related to other needs. I think that it's not just us, and that's why I want to step back and say we've done it, but how can we help other people do it? Like in FFmpeg, if you read a RTP stream that's coming from an external encoder and the encoder restarts, currently you're not going to get something very successful, because FFmpeg can do some limited content concatenation, but it cannot really do it in a dynamic way where you suddenly change the source in the middle of the encoding. And so I'm hoping that by extracting some of the knowledge from here, we can create maybe a library of functions that can be reusable outside of our project itself. So I'm going to do a quick demo, and let's hope that it works, because that's demo for you. So I have the script. Let me put that here. I have the script from, and that's not going to work at all. Yeah. I have the script from the, oh dear. Yeah, well, shit. I have the script from the last time. All right, no demo. Do it another time. Sorry, it's just the two screen is too confusing. I'll do the demo at the end. All right. I'm back. So, if we don't do a demo, I'm going to explain what is streaming, how you create a streaming loop. What you need to do is that you take a frame duration of 0.02 seconds. You start at a certain time. You use a clock to measure time. It can be your CPU. But if you're using other things like SRT input, the clock, the synchronization is going to be given by SRT. If you're using your sound card, it's going to control your latency. Not going to get into that. That's not for today. But for today, we take Unix get time of day. We measure the initial time. Then we run our program. And our program is going to generate 0.2 seconds of content, send it to our output, and say done. That's our ending time. And then we have two scenarios. If the lapse of time that we have used to create and output all that is less than 0.2 seconds, we are good. We can sleep a little bit. We come back later, and we can create content in real time. If we have done more time than that, it's going to be a problem because we're late. Maybe we can catch up. Maybe it's temporary, but most likely than not, your system is not able to handle streaming. But that's how you run a streaming loop, essentially. There's a lot of complexity under the hood, but on the higher level, that's the idea. So in liquidsoap, the way we used to do it is that we used to have a static frame of 0.02 seconds of audio PCM data. So think of these bars as little zero and floating point PCM audio samples. And we used to partially fill it up. We would pass it down to every single operator that creates data, like a file decoder would fill up your frame, pass it on to something that composes it, all the way to an output, and that output would take the samples that had been generated and output it. And the way we would do it is this way, is because this way we didn't have to reallocate content on every cycle. We just have one static frame that we pass around every cycle, and we would mark how much of the frame had been filled up, like you can see. But that was not a very useful format for content when we started adding video frame, because we want things to be synchronous, so we were constrained to have one video frame per content frame, which forced us to put, first of all, to do a sampling rate in audio that was compatible with the frame rate so that we could have one single chunk of data that was on the same boundary level, and we would assume a fixed video rate, which is not the case in a lot of content that are encoded. And it would force us to have like 0.04 seconds because of that. It was not a convenient way of representing content when we started adding video. And so what we did in the recent version is that we started thinking of content in a different way, which is that you have an empty frame and you want to fill it up. And so the intuition of filling up is that you're going to add a chunk of video content to it. It's not filled up yet, so you run it again. You finish with another chunk of content. You do the same with audio. And at the end of the day, you say, boom, right here, that's my 0.02 second of frame. And so instead of passing around a pre-allocated frame of PCM array, we pass an empty list and we just dump content into it until it's filled up enough. And what we want to do also is that if we have a little bit too much, we slice it off right here, we keep that in our buffer for the next cycle, and we pass that to the output to encode. And that's a much more rational way of thinking about it. But now the question that arises is how can you programmatically do that? And that's why we can't talk about it, because what I want to introduce here is this idea of a unified content composition API. Can we have an abstract API to compose content, to consider what is a chunk of content, what is inside your chunk of content, how do you take a chunk of content and another one and concatenate together? That's your first operation. And the second operation is how do you take a chunk of content and slice it off? Because if you remember, here we want to slice off right here. So what we're going to explore is, can we have an API that is working with both decoded and encoded, so content that is not, that is still like raw MP3 data or raw H.264 data? Can we create abstract chunk of content that can be concatenated and sliced? And we want to encapsulate the system where, from a user perspective, I'm going to say, oh, I have a chunk of content, concatenate those two or slice this, and I don't want to really know what goes on under the hood. Yeah, so let's go. So the first thing we need is content elements. So what are content elements? So, and that's something that I want to take a minute to think about, because the audio content is vastly different from video content. And you don't manipulate them the same way. Typically, if you think about decoded data, an audio content would be a PCM array, which is here 5 samples of audio floats that represents digitized point on a curve that's like a sine or frequency based. But for video, you have just a single video image is your base content. And that's just vastly different. Like in video, you can do nearest image resampling. Most of the time it's going to work because of Rutinian persistence. With audio, no. Like you can't just manipulate elementary samples. They just need to come together with a significant enough amount of data. We'll come back to that because the same problem arises in encoded format. And so let's go into it and say, what is a packet? So I'm going to use the terminology of FFmpeg here, which says a frame usually talks about decoded content. Packet is encoded content. And packet is encoded content, meaning like it is going to be a natural boundaries for it. So for instance, if you have MP3 data, there's a natural notion of MP3 frame. It's in the spec of MP3 data, and so that's like a fixed amount. I think it's 1044 samples of audio. That just gives you a chunk of the encoded data. For OGG, you have a notion of OGG packet. That's a packetization in the mixing system. For video, most videos format will say one chunk is a frame, which is an image. But they have different nature. If you're familiar with it, you have an iframe who can be decoded separately. You have a p-frame who needs an iframe to be decoded. But what FFmpeg does here is that it abstracts away what is the packet and just tells you, here's a packet. That's just a opaque and unbreakable amount of data. It holds a little piece of your encoded data, but you can't really look into it. You can't really break it up into a smaller chunk. So the second thing we need is to create our chunks. So this is our timeline, and here this timing point is 2 ways of describing it. If you're with decoded content, you call that a PTS. That's the time at which you need to be presented to the people watching the video. If you're in encoded world, it's the decoded timestamp. That's the time it needs to be given to the decoder, and we'll come back to that. You have a duration for your chunk of data, and that gives you right there your elementary first chunk of data. That's the most simple element. You have a frame, it has a certain duration, boom. You have a little tiny bit of content. You have a packet, it has like an MP3 frame, it has 1044 samples of audio, 44K rate, boom, that's a little bit amount of data. You have one image, it has a little duration. And now you want to compose your stuff. You have 2 chunks here, and because remember that we have duration for all these things, so imagine that those are no longer samples, right? They're like frame, packets, little elementary. We have a duration for it, and we have a last PTS or DTS, a last timestamp for that. So what we can do is we look at the other chunk here, That's the first timestamp. And so we can basically say the last timestamp is going to be the first timestamp of the first chunk, the first content element in its chunk. And then one by one we can adjust based on the duration, which would be the timestamp of number 2 and number 3. And now it's going to flow right because the first timestamp of the first content element here can be placed right here, and we have a concatenation. That's simple. And this will work at the mixing level. Now, the second problem we have is about slicing content. Remember I was saying we want to slice this. We want to be able to divide this content into a smaller chunk. So the way we're going to do it is we're going to take, again, a chunk of content, five packets, 5 frames, and we're going to say, well, here's an abstract offset, and here's an abstract duration. And we're not going to do anything. We're just going to say our content is 3 elements, the raw content, an array, a list of the data that's inside, and just an abstract offset and duration. And then if we have another one that's like here, another content, 2 offset and duration, we can say now, I would just want to say they are placed next to each other. That's our composition. And what we're going to do is once we compose our final content chunk, we're going to extract the content elements that are relevant within the boundaries of our offset and duration. So when I want to create the final larger chunk, I'm going to take everything that's in the yellow and orange area, adjust the timestamps, that's my new content. That is on the surface what we've done. We've implemented a notion of content in liquidsoap that extracts chunks of data from the decoders that are packets from FFmpeg or frame from FFmpeg. They are placed into arrays. When we want to do a smaller one, we just adjust the offset and duration. And when we want to concatenate, we just list them together. And eventually, the encoder, the output, is in charge of recomposing that content description to generate the data that's going to flow out. It works, but it doesn't work in all situations. Because, as I said, the beauty of an engineer, good engineering work is about having that exposed to the user, but internally being like, it's a bit more complex, I'm just not showing you that. And if you think about it, that's already what FFmpeg does, because FFmpeg gives you an API that says, you know, get stream frame, returns a packet. You don't know what the packet is. Decode packet gets a frame. You don't know what the frame is. Send the frame to a muxer. You don't know what the muxer does. So that's what we're trying to do here. Is the same idea, is that under the hood, FFmpeg knows that if your muxer is an MP4 container or an MPEG TS, then they're going to do different things, but you don't need to know. And so what I've presented here is really nice. It's elegant. It works. But there are things that I'm hoping we can solve that the user doesn't need to know that are pretty complex. So this is what we're going to talk about now, is the hard bits. First of all, let's talk about what we just saw, which is slicing off a smaller chunk of content based on a larger one. It's not always possible. It's not always possible because you have limitations. Chunks have a minimal size. So if you take one sample of PCM audio, its duration is 1 over the sample rate. And you can't really slice it to less than that. So here, typically, if my chunk was PCM audio, I would be incorrect to assume that. Because I can't really take an offset that's in between samples. It doesn't make sense. My digitization level my granularity is at minimum 1 over sample rate. You have the same problem with video frame. A single image is 1 over 25, 1 over 30, whatever is your frame rate. You can't really slice it less than that. And then for encoded packets, it's even more complex than that because we don't really know what's inside. It just tells you there's a packet. You can't really slice it. So here's one thing we've done here that I'm going to show some of the ideas we have. I'm going to expose other problems, and then we can talk about it later. So one of the solutions we found for the PCM audio, if you think about it, in your system you're going to have audio and video that flows. inside internally. And every computer system is internally digitized in a specific sample rate. There's no continuous. So your application needs its own master rate that is then converted into audio rate, video rate. And most of the time, the audio rate is much higher than the video rate. It's like 44 it's 44K sample per second, 25 frames per second. So what you can say is just set your application's main rate to be the same as the audio rate. Internally, you flow everything in 48K. Your application handles everything at 48K. And that means that your offset is always going to be on the sample boundary. You can't really mess it up. That's a solution. In videos, you can do the nearest image resampling. As I said, retinal persistence works. And for encoded packet, it might work for some formats. You might be able to do something. Some other you can't. And so typically for image, I say that an encoded frame can be a single image. So if it's a single image, you can always change its location in the timeline. You change its timestamps. Retinal persistent make it possible to put it at any offset you want. So that's going to work. The other thing you have is that if you think about the fact that that's an example of content that is not at the exact boundaries that you're going to have a little bit of delta in each case. But what you could do when you do your API is compose your content and keep a delta that's within acceptable boundaries. For instance, granting that the average delta in your little boundaries that were not exactly where you wanted to slice, it's still on the average 0, or within one of the accepted delta between audio and video. So those are different standards depending on Europe and the US about how much the audio can be late compared to the video. So if you keep that within the boundaries, you can still have a very high-level API that allows for content composition and hides a little bit of this complexity that you cannot actually slice properly, but overall it's going to function as if you had done it. So the last bit that I want to show before we finish is, of course, I've saved the most important complexity for the end. This is a timeline of video frame. But in encoded video, usually you have an iframe, which is a frame that can be decoded separately. You take this frame, you decode it, you get an image back. And then usually you have frames after that needs the first iframe to be decoded. And you might as well have frame before that who also need to be referencing the iframe after them to be decoded. So that's a timeline in presentation timestamp. That's what you want to see in the final video. But that means that the timeline in the decoder way is going to be way different. It's going to be completely jumbled because in terms of the decoding, you need to give the iframe first to the decoder so that it has it, and then you give the first blue frame that are before so that they can be decoded first. Then you give the frame after so that they can be decoded after. And so that means that your timeline in terms of encoded content is going to look very different than your timeline in terms of decoded content. And so if you don't pay attention to that detail, and you say, I'm going to take a chunk of content that's right here, and just ignore the iframe and take, that's my chunk of content, it has the 2 blue frame, the 2 green frame, well, in and of itself, it's not going to be decodable because you don't have the iframe that refers to it. And so one of the problems we had to solve is that if you're handling dynamic content and you're composing from 2 different streams, you have to ask yourself, like, is this stream the same as the previous one? Then in this case, I can probably concatenate whatever I want because I'm assuming that whatever iframe was required to decode that chunk of content was already given to the decoder in the previous one. But if you're switching streams from a different source of encoded data and you want to compose the content, then you're going to have a limitation that says, I want the first chunk that comes out of the new stream to start with an iframe so that we don't have a glitch to the user. Or you can want a glitch, but that's a presentation for later. So that's another problem that you have to solve when you want to create your nice composition algebra. And there are more questions that we haven't solved. Can you compose? So again, those goes to problems that are very low level and dependent on your mixer and encoded format. For instance, if you look at H.264 and MP4 or MPEG-TS, can you compose two streams that have different frame size? Can I change the frame size dynamically? Can you change the pixel format? U420, U422? Is that part of the standard? Is not part of the standard? Can you change the audio sample format? Another problem that you have is what in FFmpeg is called extra data. So basically, when you have encoded content, you need certain data to be able to decode, like Huffman tables for compression. And depending on if your container, in MP4, this is going to be in the global header at the beginning of the file. In MPEG-TS, it's going to be in every frame. So if I'm composing content dynamically, I need to be able to detect that and say, no. You need to convert your H.264 from global to local data so that you can compose dynamically and be able to decode. So typically FFmpeg has what they call bitstream filters that can be used to manipulate that extra data and go from a global header format to a local frame format. Again, I'm hoping that if you write an extract API that does these two things, concatenation and slicing, it can also detect those things and do it for you. The same way that when you compose content with the FFmpeg API, it's able to do it on a file. Like if you write an MP4 file, it's going to do a global header. If you write MPEG-TS, it's going to do it for you. Yeah, and the other thing is that it's not always going to work. So what are the optimal parameters? How many iframe do you need? So those are like the hard questions. So yes, I'm finished now, and I think we're going to forego the demo. I wish I could have done it. But to recap, what I was trying to present is if we want to manipulate content, and especially manipulate raw encoded content, binary content, can we create an API that allows to consider your content a little bit of pieces that you can slice up, patch together, send to an output, and create a stream that is a valid stream without having to re-encode everything, and also abstracting the complexity. In the demo I wanted to show, it was a 4K video, well, a bunch of 4K files and some audio, and basically I click on certain button and it switches the file on demand, and the content keeps being decoded without any glitch. And I think that there's a lot of value to that. I think that a lot of the computing power that's required to re-encode to make that work in most applications could be saved if we can work on specific expert knowledge about all these binary formats and export that in a very neat API that would solve the problem for a lot of people. Thank you. So yeah, maybe there are remarks or questions. Yes?
In your experience, have downstream receivers been willing to accept the level of AV synchronization that you're introducing with this solution?
In our current solution, so what we're solving at the moment is a very simple subset, meaning that it works if your system has been preemptively designed to work properly. So I haven't done a lot of testing in, specific situations where the AV gets, like that idea of maintaining an average AV desynchronization, we don't have it yet. It's ideas for future development. Well, if I have a couple of minutes, I can try that demo. The problem I was having is that the screen is not screen. Where is it? No, display. There you go. All right, arrange. No. Mirror. Is that, can you see what I'm seeing? Yes. All right, so let's try the demo here. This is my script in liquidsoap. I'm going to start it. It's going to create a HLS stream. Yep, the files are started. So the music is mine and the video is free. So we're going to look at the telnet interface. We have two commands that says audio next. What's the next audio file? And audio skip. So I'm going to skip audio 2 times. All right, and now I'm going to do the same with video. So that's the next video is going to be number 1. then number 4. All right. And now let's listen to the result. That's the video we switched 2 times, and now that's the audio, and now that's the video. Wait, it's a 20-second loop. There you go. So yes, what we're seeing is that we're switching seamlessly from the different files. And they're all 4K. I'm not re-encoding them, but the content is we're able to do that streaming loop where we do 0.2 seconds of it. We slice them up, we compose them, and there's no glitch because the iframe is properly placed first. All right. I hope that makes more sense now, and I want to thank you, everyone, for being here today.
Does your solution have any requirements relating to OpenGOP versus ClosedGOP for the source files?
Oh, sorry. What do you mean exactly?
Well, like when doing splicing, in many cases, like whether or not you have OpenGOP versus ClosedGOP, like affects the interdependency between like the iframes and so forth.
No, again, I am not doing a lot on the video side yet. It's as I said, I should have been more clear at the beginning. Liquidsoap is more high level, so I'm not myself an expert in all the different binary content. I have been working straight up with what FFmpeg gives me as an API, and part of the reason I'm giving that talk, to be honest with you, is because I'm hoping that more expert knowledge in the binary formats, in the different encoders, in the different muxer, could help inform that. The set of questions I had at the end about things like, when I was saying this, I don't have the answers to that. I'm actually seeking them myself. Like, can you change the frame size? Can you change the pixel format? What are the limitations? We have solved the problem in a very specific case. We're very strict. When we compose, we want the exact same codec, the exact same frame size, the exact same pixel, and it works if you tested it, basically. But thank you for your question. And maybe, yes, absolutely, yeah, I would love to learn more, absolutely. All right, I think that I'm done, right? Yep, time's up. Thanks, everyone. Y'all have a good day.